We have a cylindrical container filled with snow cone syrup, has a diameter of 4 inches and a height of 10 inches. Diameter is 4, which means the radius is 2. The height is 10 inches. The container is full of syrup and leaking at a rate of 2 inches cubed per hour. So that's the rate of the volume. So that's leaking, so that means it's decreasing by 2 inches cubed per hour. So that's why I have to put a negative. The syrup is leaking into an empty conical snow cone cup with a diameter of 2.5 inches and a height of 3.5 inches. Here's a cone. Diameter is 2.5 inches, so that means the radius is half of that. And the height is 3.5 inches. For part A, how fast is the depth of the syrup in the cylinder changing? So that's going to be the height, so dH over dt, of the cylinder when the level in the cylindrical container is 8 inches high. So that's when H is 8. So we have to use the volume formula. Volume is the area of the base times the height, which is pi r squared h. The radius is going to be constant here because it's not changing. The only thing that's changing here is the height. So we can replace r with 2 because that's the radius. So this is 4 pi h. Now we can take the derivative with respect to time and get 4 pi dH over dt. We're given the derivative. dV over dt is negative 2. And so we want to solve for dH over dt. So divide both sides by by 4 pi. We get negative 1 over 2 pi dH over dt. So the volume is decreasing, which you would expect the height to decrease as well. And the units here are just going to be inches per hour. So that's part A. Part B says, at what time will the cylindrical syrup container be empty? Well, for that, you want the volume to be 0. So if it's leaking negative 1 over, if the volume is decreasing by 2 inches cubed per hour, how long is it going to take for the cylinder to be completely empty? Well, what is the volume of the whole thing? Volume is pi r squared h. R is 2, h is 10. So this is going to be 40 pi inches cubed. It's leaking at 2 inches cubed per hour. So I'm going to take 40 pi divided by 2. That's going to be 20 pi hours. Okay, so you can think of this as like a distance equals rate times time, dirt formula. Distance here being the volume, the total volume being 40 pi. The rate at which it's decreasing is 2. And you say, okay, how long is it going to take? That's time t. So solving for t, you have to divide both sides by 2 to get 20 pi hours. Now part C, at what rate is the depth of the syrup in the canonical cup rising when the syrup in the cup is 1 inch deep? Okay, so for the canonical cup, we know the volume is 1/3 pi r squared h. The only thing that's changing is the height. The radius is the same. So we're going to say the radius is 1.25. And I'm going to square that and multiply, or I guess, yeah, we'll square it. We'll leave it as it is. So it'll be 1.5625 over 3 pi h. Now we'll take the derivative with respect to time. So that's going to be 1.5625 over 3 pi times dH over dt. So what's happening here is this cylinder is leaking into this cone. So the rate at which this is leaking is the rate at which this is growing. So if the volume here is decreasing by 2, that means the volume is increasing by 2 here. So dV over d2 has to be positive 2. And so now we can just solve for dH over dt. And so we'll multiply by 3, divide by 1.5625 pi, and this is going to be in inches per hour. And that's our answer.